So in this video, we're going to buzz through two quick examples of evaluating a geometric series. And we're given some information here at the top. A1 equals 2, R equals -2, and it wants to know the explicit formula. So we haven't gotten to the series part yet. But if you remember what the explicit formula is for geometrics, it's AN equals A1 times R to the n minus 1. So all you do is you just plug everything in, right? This becomes 2 times R is -2. And I like to put parentheses around these things just to keep it real clear. Say you were going to plug it into a calculator. Calculators get confused easily, so I like to make my parentheses clear. Now we're going to keep using the same sequence, but we're going to add up the first 7 terms of the sequence. This is a sum. Okay, when you see the word sum or adding terms or whatever. Now we have to use this formula, Sn equals A1 times 1 minus R to the n. I say you have to use this formula. That's not actually quite true. You don't need to use this formula. It's there as a matter of convenience. If you want, you could calculate the 7 terms separately and then add them together. But I think there's a lot more room for error if you do it that way, because every time you make a calculation, you have a chance that you get something wrong. So A1 equals 2. 1 minus, what's R? Oh, we found R already. That's -2. Okay, so this is -2 to the 7th power. And on the bottom, it's just 1 minus -2. Now, we have to be careful about these negative signs. Notice that I'm putting them in parentheses. If you're plugging this into a calculator, you need those parentheses around negative signs, fractions, otherwise the calculator gets real confused. Because, I mean, calculators are kind of idiots. They don't actually know what's going on. They only know what you type to them. So if what you type is not perfectly clear, there's going to be an error. So I just plugged in -2 to the 7th, and I got -128. Okay, I'll just keep that bottom right there. Now, we have to simplify this a little bit. So remember that when you subtract a negative, that's just like adding a positive. So on the top, I really have 1 plus 128, and on the bottom, I have 3. Okay, and we can go on and simplify this thing. I don't think it's really necessary. You get the idea. This is how you evaluate a simple summation. Now, in the next example, this is another summation problem, but there's no real words at the top. So you have to know, this is important, you have to know what that means. This is the summation symbol. And when you see that, it means heads up, we're taking a sum. Okay, so we're given some information here, but it's not all laid out for us very clear. Like, remember in this first one, it said, hey guys, give me my pen back. The first term is 2, and here's the ratio. It's this. We were told very clearly what these things were. Right here, you're not told very clearly what they are, but all the information is present for you if you know where to find it. Okay, so I'm going to need this space right here. Go away. So I want you guys to remember that whatever follows the summation symbol is your explicit formula. That's where an explicit formula goes, right after the summation sign. And since this explicit formula is A1 times R to the n minus 1, all we have to do is look for the n minus 1 in the exponent to know what R is. Okay? There's R. It's -4. And the first term, that's, whatever comes before R. So there's my first term, -2. If you don't see a number there, if all you have is R to a power, then the coefficient before it is 1. Remember, when you're multiplying by 1, that usually just gets left off. They don't write it. Now it's time to figure out what the sum is. And remember our formula, Sn equals A1, 1 minus R. Come on, pen. 1 minus R to the... What's going on here? Come on. 1 minus R to the n over 1 minus R. And we have to figure out what n is. It's not n equals 1. That just means we're going from the first term to what? The 9th term. Okay, so if we're going from the first term to the 9th term, that means there are a total of 9 terms. So here's our formula. It's 1 minus R to the 9th. It's going to be big. Yeah, it's going to be real big because first term is -2. 1 minus negative 4 to the 9th power, and 1 minus negative 4 on the bottom. So that's going to be a very large number. I don't know, hundreds of thousands maybe. Simplify this, get your answer in here. That's what this problem's all about.